Okay, up until this point, we have been able to use our unit circle and our 30, 60, 90, and 45, 45, 90 triangles to find values like sine of 30 degrees or tangent of 135 or cosine of 45 degrees. However, let's suppose for a second that we were interested in finding the sine of 75 degrees or the cosine of 15 degrees or the tangent of 165 degrees. Well, clearly none of these angles are on our unit circle, and so the question is there a method, is there a way, is there a formula for us to be able to find certain angles and the trig values of those angles, sine, cosine, tangent, secant, cosecant, of these angles that are not on the unit circle. And so today we are going to be looking at several different formulas that will enable us to find the values of these functions. And so the first we're going to look at is sum and difference formulas. And so here we have the cosine of a plus b, or cosine of a minus b, is equal to the cosine of a, the first angle, times the cosine of b, the second angle. Now I want you to pay close attention to this. Here's a plus or minus here, and it is reversed here. It is minus plus. So if you are summing up two angles, then the sign that you need to use here is a minus. So the top sign goes with the top sign, and the bottom sign goes with the bottom sign here. So this is really just simple. All you really need to do is find two angles that will add or subtract to the angle that you're trying to find. So 75 degrees. Well, we could pick 30 plus 45, which would probably be the wisest thing to do. Or we could pick let's see, we could pick 120 minus 45, and that would also get us to 75. But we are just going to pick for right now the simplest two that we can find. And so we are going to pick, we're going to break this up as cosine of 30 plus 45. And so we're going to plug that into our formula. So our formula says it's going to be the cosine of A, which is the first angle, times the cosine of B, which is the second angle. And the top sign is plus, so we need to use a minus, minus the sine of A times the sine of B. All right, so we can use our unit circle, or better yet, our 30, 60, 90 triangles, and we can find these values. For the sake of time on this video, we're going to just give them to you. Cosine of 30 is root 3 over 2. Cosine of 45 is root 2 over 2. Sine of 30 is 1/2. And sine of 45 is root 2 over 2. So you multiply root 3 times root 2, and you will get root 6. And 2 times 2 on the bottom gives you 4. And then 1 times root 2 is root 2. And 2 times 2 is also 4. And so your final answer here is going to be root 6 minus root 2 over the common denominator of 4. And so that would be what the calculator would give you. If you did cosine of 75, it would probably give you a decimal answer. And so that would be the same as root 6 minus root 2 over 4. All right, so let's do the next example. And it says sine of 7 pi over 12. All right. Now, you could change this into degrees, and you could do it that way. You can either do it that way, or you can just keep it in terms of radians. So if we keep it in terms of radians, this is going to be, well, you're going to have to find two angles that add up or subtract to 7 pi over 12. So the first two come to mind would be 3 pi over 12 plus 4 pi over 12. Now remember, the angles that you choose must be angles that are on the unit circle because those are the only ones that you know the sine and cosine values of. So 3 pi over 12 is the same as pi over 4, which is 45 degrees, and 4 pi over 12 is the same as pi over 3, which is 60. So really this is 45 plus 60, which is sine of 105 is what we're really interested in. So let's see if we can figure out how to use this formula. So it's the sine of A plus B is equal to the sine of A cosine B plus cosine A sine of B. So we're going to plug and chug. So sine of A, which is sine of 45, cosine of 60, plus cosine of A, so cosine of 45, and then sine of 60. All right, so we're going to just figure out our unit circle values here. Sine of 45 is root 2 over 2. Cosine of 60 is 1/2. Cosine of 45 is root 2 over 2. Sine of 60 is root 3 over 2. And so we're going to end up getting something that looks similar to the answer we got before. It's going to be root 2 times 1. That's simply going to give us root 2 over 2 times 2, which is 4, plus root 6 over 4. So our final answer, we've got a common denominator, so it's going to be root 2 plus root 6 over 4. And that is the answer for the sine of 7 pi over 12. All right, so let's see if we can now do this third example, tangent of 75. So this one is a complicated formula. And by the way, on any quiz or test, you will have these formulas given to you. So you don't have to memorize them, but you do need to know how to use them. So it says tangent of A plus or minus tangent of B over 1 minus or plus tangent of A, tangent of B. And so we are going to break this up as tangent of, we'll just use 30 and 45 again. So this is going to be, if we follow the formula, it's going to be tangent of 30 plus tangent of 45 over 1 minus, because notice we're using the top sign, 1 minus the tangent of 30 and tangent of 45. All right, so if we're not sure what the tangent of 30 is, no problem. We are just going to draw a reference triangle, and we're going to put 30 degrees there. We're going to put 60 here, and we are going to label our triangle. So that's going to be 1, it's going to be root 3, and that's going to be 2. So the tangent of 30 is simply going to be opposite over adjacent, so 1 over root 3. So we can go ahead and plug in 1 over root 3. Tangent of 45, well, let's review that. You have a 45, 45, 90-degree triangle. So the sides are going to be 1, 1, and root 2. So tangent is going to be opposite over adjacent, 1 over 1. So that's pretty simple. That's just going to be 1. Over 1 minus the product of those two. So it'll be 1 over root 3 times 1. Now, what I'm going to do here, I see a root 3 on this bottom. I see a root 3 here. I'm just going to multiply the entire top by root 3. So I'm going to multiply by root 3 on the top and the bottoms. That means I'm going to have to distribute this root 3 to both terms on the top, and I'm going to have to distribute it to both terms on the bottom. And that's just a quick and easy way of getting rid of the denominators. So this root 3 times 1 over root 3, the root 3's are going to cancel, and that's going to leave me with 1. Plus, root 3 times 1 is root 3. On the bottom, we have root 3 times 1, which is root 3. And then root 3 times negative 1 over root 3. The root 3's cancel, and I'm just left with minus 1. And that's about as far as you need to go for these problems. All right, so now in this example, we want to go backwards, and we want to figure out what is the angle that we are trying to find and whether it's the cosine or the sine of that angle. So letter A, they give us sine of 42 cosine of 17 minus cosine of 42 sine of 17. So you're going to want to look at the formulas and see which formula matches up perfectly with this. This looks like sine of A, so maybe we'll put A. This looks like sine of A cosine of B minus cosine of A sine of B. And so that looks like is going to be this formula right here. So all we need to do is figure out what A is and what B is. So this is going to be sine of 42 minus 17. Our A is 42, our B is 17, and we see the negative here, so that's going to be there, that's going to be there, so we know it's the subtraction of the two angles, not plus. So 42 minus 17 is 25, and we are done with this problem. Real simple. Sine of 25. So we're basically just going backwards. All right, part B. Cosine of 94 cosine of 18 plus sine of 94 sine of 18. So once again, we will say that our A must be 94, our B must be 18. Our A is 94, our B is 18. And so we look at this formula here and we recognize that it is going to be cosine, and we remember that if this sign is positive right here, that means we need to link it to the bottom. That means we're using the bottom, so it is the subtraction of these two angles. So it's going to be the cosine of A minus B. So it's going to be the cosine of 72, actually 76 degrees. And that is the answer to this one. All right, in this example, it wants us to prove this identity that the cosine of x minus pi over 2 is really equal to sine of x. And so we first recognize that this is the difference of two angles, cosine difference formula. So we're going to be using this formula right here, and we're going to be using the lower symbol, which means over here it's going to be a plus. All right, so let's see if we can break this down. Our A is x, so we'll call that A. Our B is actually an angle that we know, pi over 2. So we're going to plug it in. So it's going to be cosine of A, which is x, cosine of B, which is pi over 2, and we're going to be doing plus sine of A times the sine of pi over 2. Well, pi over 2 is 90 degrees, and the coordinates for 90 are 0, 1. And 0 is your cosine, and 1 is your sine value. Remember, cosine is x and sine is y. So cosine of x, well, we don't know what that is. We're just going to write cosine of x. Cosine of 90 is 0, and then plus sine of x. Well, we don't know what x is, so we have to leave it there. Sine of 90 is 1. So 0 times anything is 0. Sine of x times 1 is just simply sine of x. So we have proven the identity. Cosine of x minus pi over 2 is equal to sine of x. All right, the next set of formulas we're going to learn are called the double angle formulas. And actually, I'm going to prove to you that these formulas here are really just derived from using the sum and difference formula. So for instance, let's take sine of, we're going to just use x instead of u, sine of 2x. And it says here on our formula that it's equal to 2 sine of x cosine of x. By the way, it's called double angle formula because that is just x, and this is double that, or twice that. That is 2x. So why don't we break this up, and we'll say sine of x plus x. So x plus x is 2x. So that means our a is x, and our b is also x. So we're going to use the formula that you have on your notes, which is going to be sine of a cosine of b plus sine of b cosine of a. Well, look, you get sine of x cosine x plus sine of x cosine x. That's equal to 2 sine x cosine x. And so we've just proven the double angle formula really simply comes from the sum and difference formulas. So now we're going to use these in a problem and see if we can solve the problem. So we are given the problem cosine of 2x plus cosine of x equals 0. I want you to notice here for a second that the double angle formula for cosine has 3 different choices that you could use for it. All right, you've got cosine squared minus sine squared. You've got 2 cosine squared minus 1. You've got 1 minus 2 sine squared. And all of them will give you the same answer, but there's normally one that's wiser to use. Now let's think about it. We've got all cosines in our formula here. So it would be best to use the formula that has only cosines in it. So you can't add 2 trig functions together that have different angles. They're not like terms. So we got to get everything in terms of x. So we are going to replace cosine of 2x with this formula right here. So we're going to say 2 cosine squared of x minus 1 plus cosine of x equals 0. And then we are going to treat this like a quadratic equation, and we're simply going to factor it. So that gives us 2 cosine of x, and over here we have cosine x, and we need a 1 and a 1, and the middle term needs to be a positive 1, so that's going to be plus, that's going to be minus, and we're going to set these equal to 0. And so if we set them equal to 0, we get cosine of x equals 1/2, and cosine of x equals -1. Now we have to think on our unit circle, where is the cosine of x equal to 1/2? Well, let's just see if we can draw a little triangle here. Cosine is going to be your adjacent over your hypotenuse. So there's going to be an angle in quadrant 1 and quadrant 4. So adjacent over hypotenuse, adjacent over hypotenuse. So that's going to make this side √3 and √3. So that's going to be 60 is always across from √3. So we'll put 60 there. And so one of our answers would be 60 degrees. For right now, we'll leave them in degrees. And the other angle would be 60 degrees rotated down, which would be 300 degrees. So these two solutions come from this one. And then now we have to look at when is the cosine of x equal to -1? Well, once again, cosine is your x coordinate. So if we remember that there are some special angles that are on the unit circle that are on the axis, we remember at 180, we have the coordinates -1, 0. So that means that the cosine of x would be equal to -1 when the x coordinate is -1, so that would be 180 degrees. So these would be the 3 solutions that you'd want to have for this problem. All right, I hope you're ready for a challenge. This is a tough problem. So we have sine of x plus sine of 3x equals 0. So we are okay with sine of x, but we need to work on sine of 3x. So we're going to start by obviously breaking this up into the sum of two angles. So that's going to be sine of 2x plus x equals 0. And so now we're going to use our sum formula for the sine that you have on your notes. So this is going to be sine of x, which you're going to bring that down, plus, and it's going to be sine of a cosine of b, plus the sine, or should I say cosine of a sine of b equals 0. All right, so here is the key to this whole problem. Because we cannot change this sine of x into anything other than sine of x, what we need to do is we need to manipulate these double angle formulas so that they only have sines in them and not cosines. So essentially we want to get a problem that has all sines in it and not cosines. So we'll just bring this down. So it's going to be sine of x plus sine of 2x. Well, that only has one formula. So we don't have different options as far as what we can plug in for sine of 2x. So that's just going to be 2 sine x cosine x. Now we got to bring down this cosine of x. So times cosine of x plus cosine of 2x. Well, we are going to use this particular one of the three because once again, we want to get everything in terms of the sine function. So cosine of 2x is going to be 1 minus 2 sine squared of x times this sine of x. All right, so now we are pretty much, we've got everything in terms of, notice, x, 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 x. No 2x, no 3x. We've got all of these in terms of x, which is what we want. So now we're going to just write it out. Sine of x plus 2 sine of x cosine squared of x, because I'm multiplying these two together, plus I'm going to go ahead and distribute this sine into both of these. So I'm going to get sine of x minus 2 sine cubed of x. Now don't get nervous with the cubed because it's going to go away. Or actually, we're going to combine it in just a moment. Because we're going to change cosine squared. We're going to change that into 1 minus sine squared. So I'm going to continue up here. We have sine of x plus 2 sine of x times 1 minus sine squared of x plus sine of x minus 2 sine cubed of x equals 0. So now I'm going to go ahead and distribute this sine, 2 sine of x in here. So that's going to give us sine of x plus 2 sine of x minus 2 sine cubed of x plus sine of x minus 2 sine cubed of x equals 0. Okay, we've got some like terms. We've got sine of x, we've got sine of x, and we've got 2 sine of x right there. So that's going to give us 4 sine of x. And we also have these two like terms as well, negative 2 sine cubed and negative 2 sine cubed. So that's going to give us negative 4 sine cubed of x equals 0. Well, I see some greatest common term. They both have a 4 and they both have a sine. So I can factor out a 4 sine of x. And that's going to leave me with 1 minus sine squared of x equals 0. And now we're going to set both of these equal to 0. So we're going to have 4 sine of x equals 0. And then we're going to have 1 minus sine squared of x equals 0. Well, where is the sine function equal to 0? Well, that's just going to be 0, pi, and 2 pi. Now, where is the sine? So if we solve this by moving the 1 to the other side, I'm going to continue up here. It's going to be sine squared of x equals 1. So take the square root of both sides, and you will get the sine of x. Don't forget, anytime you take the square root, you need plus or minus on your answer. So now you think, where on the unit circle is the sine or the y value 1 or negative 1? Well, that's going to be north, call that pi over 2, and south, 3 pi over 2. And so you see here that this one has 5 solutions to it. All right, for the sake of time, we are going to skip the power reducing formulas, and we'll cover those in class. But right now, we're going to work on the half angle formulas. And so sine of 15. Now, certainly, we know that we could use our sum and difference formulas that we learned at the beginning of this video, and we could actually do sine of 45 minus 30. All right, and we could get the same answer. However, we are going to use our half angle formulas here, and we're going to get it that way. So sine of 15, what you need to do is we need to figure out that 15 is actually half of 30. So what we're going to do is we are going to rewrite 15 as the sine of 30 over 2. 30 is your u. So that's going to go there, right there. So if you are trying to find sine of 15, you need to rewrite 15 as 30 over 2 and basically just plug it into the formula. Now, I do want to pay attention to this plus or minus right here. So this plus or minus, you have to figure out whether it is plus or whether it is minus. Do not write down plus or minus. You need to think about what quadrant 15 is in, 15 degrees is in, and what would the sine of 15 be? Well, 15 degrees is in the first quadrant. So the sine is positive in the first quadrant, so therefore you will use a plus. All right, so you can either just use a plus or just leave it off. But it's going to be the square root of 1 minus the cosine of 30, not 15, because you don't know anything about 15. You know the cosine of 30 over 2. And let's keep going here. So you'll have the square root of 1 minus, well, the cosine of 30 is root 3 over 2 divided by 2. And so now all I'm going to do is I am going to multiply the top and bottom by 1/2. That's the same as dividing by 2. So on the bottom that goes away, and here we're going to distribute the 1/2 inside, and we will get a final answer of the square root of 1/2 minus root 3 over 4. And actually, we're not done yet. We're going to get a common denominator, and we're going to make this square root of 2 over 4 minus root 3 over 4. And we're going to keep going, and we're going to get 2 minus root 3 over 4, common denominator. And then we're going to go one more step, because we're going to recognize that the square root of 4 is simply 2. So now the square root only needs to be on the top part, and the 2 can be on the bottom because we're taking the square root of 4, and that is going to come out. And so that's going to be the answer to this one. All right, let's go ahead and do cosine of pi over 8. All right, now pi is 180 divided by 8. And so that's going to be 22.5 degrees. So 22.5 degrees is half of 45. So we can write this as the cosine of 45 over 2. And so 45 is our u. So that's going to go there, and that's going to go right there. Now, 22.5 is in the first quadrant, and so everything is positive in the first quadrant, so we don't need the plus or minus. We know that it's going to be plus. So it's going to be similar to the last problem. It's going to be equal to the square root of 1 plus the cosine of 45 over 2. Cosine of 45 is root 2 over 2. So 1 plus root 2 over 2 divided by 2. And that's going to be, once again, we're going to multiply by 1/2, top and bottom. And you can see where this is going. So you distribute the 1/2 in here, and you will get 1/2. This is going to cancel, plus root 2 over 4. This is going to be 2 over 4. So this is going to be 2 plus root 2 over the common denominator of 4. And then we'll finish it all the way up here. We're going to take the 4 out, so it's going to be 2 plus root 2 over 2. And that is the answer to the cosine of 22.5. And we will go over the other ones in class tomorrow.